Red light's on. Good. Okay, so today I'm going to show you how to use a separatory funnel, hopefully. I haven't actually looked in the drawers to make sure we have sep funnels. First thing I'm going to do, I'm going to put on my safety glasses. You'll see I'm not wearing a lab coat and I'm not wearing gloves. You guys will. We require you to use a lab coat in the lab. That will protect your clothes. It also protects you. These clothes are very susceptible to the chemicals we use in here. So if I spill some of this stuff on here, it's probably going to burn a hole. It'll definitely stain. You don't want that. The other thing is these clothes tend to be, normal clothes tend to be more flammable than lab coats. And a lab coat, if you ever are, God forbid, in a situation where there's fire or, fire mainly, get away from the fire, get away from the chemical spill, and then the lab coat just tears away, right? It's kind of an outer shell you can discard and get the chemicals or the fire or whatever off of you really quick. Right now I have no such, I don't have that protection. I can rip my shirt off, and I will if it comes to it, and you'll never see this video. But anyway, I'm also not wearing gloves. My hands are chewed up after a lifetime in the lab of not wearing gloves. You don't want that. So make sure your safety glasses are on. That's going to be priority number one. In this lab, we're going to, this is, I guess, the October 4th lab. We're going to separate compounds based on solubility. And we do this with what's called a liquid-liquid extraction. All right, so I've got, let me see if you can see it here. I've got this mixture I've made. There's a blue solid and a yellow solid. And I want to separate those. See if you can, maybe that's better. Having trouble reading, there we go. Now you could pick the little things apart with tweezers. That's going to be really hard. Instead, we're going to separate the blue and the yellow based on solubility. So one of them is going to be soluble in water, and one is going to be soluble in organic solvent. The organic solvent I'm going to use today is ethyl acetate. All right, so you can look the structure of ethyl acetate up. You should know it from last week's TLC lab. For an organic solvent, ethyl acetate's actually reasonably polar. So when we did TLC with it, it was the kind of semi-polar solvent. We also used ethanol, which is a good bit more polar. We can't do liquid-liquid separations with ethanol and water. How come? Reason is ethanol is soluble in water. And again, you guys know this if you've ever seen a beer or a bottle of wine. Okay, so to do liquid-liquid extraction, the two solvents have to be immiscible. That is, not soluble in one another. Most organic solvents, we call them organic solvents because they're immiscible with water. So ethyl acetate, dichloromethane, hexane, heptane, these will not dissolve in water. They're mostly non-polar. Like compared to water, ethyl acetate's very, very non-polar. It can't be a hydrogen bond donor. It's got the carbonyl and one CO bond that give it a little bit of a dipole. So ethyl acetate's more soluble than heptane, but not soluble like water, which has a strong dipole, lots of hydrogen bonding. Okay, so what I'm going to do, I'm just going to take my mixture here. This is not exactly the way you guys will do it in lab. Mostly what I'm going to try to show you today is how to use a separatory funnel. I tell you what, before I deal with this, let's set up the separatory funnel. You'll find in your hood a ring stand like this. Let's set this up so I can see what I'm doing. All right, you'll see a ring stand like this. Move my solvent to the side. And now you're going to want to we can affix things to this with clamps. There's a drawer called hardware. You want to look for that. And you guys should feel free to poke around the drawers in the lab. All right. Just like I said about last week. So I'm going to put this ring stand here. All right. So now I've got this ring clamp affixed to the stand. Turn this around so it's kind of over that. You want the clamp to come over this part so that the center of mass of the whole thing is over the flat bit. And then again, you're looking around. That drawer has only beakers. This drawer has flasks. This drawer has graduated cylinders. Aha. So there in this drawer, I have found my separatory funnel. So what I hold in my hand is called a separatory funnel. You need a stopper. Make sure it fits. It does. There's also this stopcock at the bottom, and that's going to, right, if I turn it this way, it's closed. If I turn it this way, it's open. If it's open, obviously any liquids in here can run out the bottom. It's kind of shaped like an inverted pear, so it's fat up here, narrow down here. You'll see why here in just a second. Here's the thing, you can put bring this out. Make sure you guys can see that. So there's the ring stand. I'm going to take the separatory funnel and I can just slide it in there like so. As it's sitting, you always want to leave the stopper out. Generally, you only want the stopper in if you're shaking it. Again, you'll see this in just a second. So I'll just set the stopper there. I also need a funnel. Wonder where I'd find a funnel. I don't remember seeing one. Ah, well, there's one. There's one here in the hood. Is there one in everybody's hood? I'll make sure funnels are out. All right, put the funnel in there. Okay, so that's going to be used for my liquid-liquid extraction. Now, I want to pour solvent into this mixture. I'm going to use 30 mils of ethyl acetate and 30 mils of water. In these extractions, oftentimes in organic labs, students come in and they want to be super precise about measurements. One of the tricks to learning to do laboratory chemistry is learning when you have to be precise and when you don't. In a liquid-liquid extraction like this, you do not need to be precise. I'm going to shoot for 30 mils, but I am not going to get too hung up on exactly how much I have. All right, so I wound up with 31. All right, 31's fine. 35 would be okay. 28 would be okay. The other thing is ethyl acetate, as we talked about last week, is a volatile solvent, so keep it in the fume hood. I'm going to add this to the beaker with the mixture, and now I'm going to measure water. Can I use the same graduated cylinder? In this case, I can, because the next thing I'm going to do with this water is pour it into the ethyl acetate. So it doesn't matter if it gets some ethyl acetate into it. Oh, 35 mils of water. That's fine. So, you know, if the instructions say 30 for an extraction, 25 to 35, somewhere in there. You don't want to waste anything, but you don't want to spend a lot of time, you know, trying to be super accurate when you don't have to be. Like I said, sometimes you will need to be. Get all this dissolved. Like I said, this is not the extraction you guys are doing next week. I'm going to pour this in there. All right. Now we'll let it sit for a minute. How am I doing on time? 8 minutes. And you can already see the colors kind of separating. Now, again, I mixed this really well when I poured it in, but the way you want to use a separatory funnel, okay? So the way you want to use a separatory funnel is to shake it. You can mix these two layers really well. So when you do that, here's how you want to do that. First, you want to make sure your stopcock's closed. Right? If the stopcock is open, everything's leaking out. I like to put the stopper kind of right there at the base of your index finger. All right, hold it there. Make sure you have the top. Make sure you're holding on to the actual funnel, not just the stopper. Right? If I just hold on to the stopper, it might come out. So okay, put the stopper right there. Hold the stopper in. Grab the top of the funnel. Invert this. Then you want to open that up. Open the stopcock up. And the reason you do that is gases can build, right? And it's a closed system. You don't want to do that. Close it back. Shake it. All right. Hold it with two hands. So stopper, base of the index, and middle finger holding the stopper, holding the set funnel. The other hand can be used, right? If you're left-handed, you could reverse your hands. Shake it up a couple of times. This gets it good and mixed. This makes sure all the solutes see both solvents. All right, so the blue stuff sees the water and the ethyl acetate. The yellow stuff sees the water and the ethyl acetate. And then what happens, right? So water and ethyl acetate are immiscible. So they're going to form two layers. And you can see that happening right now. It happens slowly, right? The layers are sort of pulling apart. But each solute will dissolve in the solvent it's more soluble in, right? So it looks like the blue stuff is more soluble in the bottom layer. The yellow stuff is more soluble in the top layer. I'll get this a little closer for you. Okay, so you can see the layers are separating. Yellow stuff, and you can also see there's some fuzzy stuff there. It's not just an even line. The more you shake this up, the more you disrupt it, the more, so this would be a sharper line if this was heptane or hexane, a more non-polar hydrocarbon. Ethyl acetate is a little bit soluble in water, so they sort of pull apart slowly. But again, you see we have separated the blue from the yellow based on the preference and solubility. Now, which layer is which solvent? My head's not on the screen there. Okay, how do you know, is this water or ethyl acetate? Is this water or ethyl acetate? Well, there's only two layers, so if you figure out one of them, you know the other one. And here's how it goes. The more dense solvent is on the bottom. Okay, so the density of ethyl acetate is about 0.75 grams per mil. What's the solubility of water in grams per mil? All right, this is a real easy number to memorize. It's 1. The density of water is 1 gram per mil. Okay, so water is more dense than ethyl acetate, so it's on the bottom. Does that mean water is always on the bottom? No. In the lab you're doing, in the extraction lab we're doing with Excedrin, we're going to use dichloromethane as the organic solvent. Dichloromethane has a density of about 1.3 grams per mil. 1.3 is greater than 1, you guys knew that. So dichloromethane will be the bottom and water the top. All right, so you just always want to keep track with density. And you can see now the layers have separated very nicely. And the yellow substance is dissolved in the top layer, the ethyl acetate. The blue substance is dissolved in the bottom layer, or the water. Well, that's great, you say, Dr. Jones. But how does that get us any, they're still in the same container. How do I separate them? Okay, so that's the brilliance of the separatory funnel. Can you see this, I wonder? So now I'm going to lower this down a little bit, get it close. The separatory funnel, having this very narrow opening at the bottom, lets us release the bottom layer and retain the top layer. So I just turn that stopcock. Again, something I want to point out, make sure your stopper is not in the separatory funnel, because watch what happens. I don't know how well you can see this, you may need to blow it up. Watch what happens if I open up the stopcock. Right, it stops, there's no flow. The reason there's no flow is I've pulled a vacuum here. So you've got to have the stopper out of there, and once you do that, the flow goes. Now, you want to very carefully, and again, I don't know how well you're going to be able to see this, probably not real well. You want to just kind of very slowly, as best you can, let out the bottom layer, keep the top layer in the top, and now I have separated the blue from the yellow. All right, aqueous layer, organic layer. Now it could come down that you're doing an extraction. Very often in organic chemistry, we're doing extractions and we just want the organic layer, or we just want the aqueous layer. And so that you're tempted at this point to toss one of them, right? I'll just go, I want the organic layer, I want that yellow organic compound, I'll just toss this out. Don't do that, all right? When you're doing an extraction, never throw a layer away until you're absolutely certain you've gotten the material that you want. The reason is, what if I get confused? I forgot what solvent I'm using, I think this is water, turns out this is organic. If I throw this out right now, and this is the organic layer, the layer I want, I've lost it. If I set it in the back of the hood, 10, 20, 30 minutes go by and I realize, oh crap, I screwed up. I've wasted some time, but I still have my layer. Okay? Once you throw material away, it's gone. So until you've isolated the material you actually want, hang on to it. All right, there you go. So I've got the blue layer. Where's a beaker? Give me a beaker. Got the blue layer, and then I can pour out the top. Right. Look at that. Now I've got the yellow layer. Now, of course, if I want the solids, what do I have to do? Well, I would have to evaporate this, right? I would have to evaporate off the solvent. I would have to evaporate off the solvent here, all right? And that would get me the yellow solid back or the blue solid. Now, oh crap, now they're all mixed. Now what I'm gonna do actually is clean up, all right? So I'm gonna move the, you might get a little dizzy, sorry. Little tour of the chem lab. All right. All right, so I'm going to show you how to clean up. Hopefully not too much. Maybe I'll just show you how to clean the sep funnel. All right, so again, you'd probably want gloves on for this. Get a nice side view of me here. The first thing I'm going to do, we've got water, we've got acetone. Which do I use to clean? Well, I'm going to use acetone, and here's why. Acetone's a nice polar solvent. It will dissolve the ethyl acetate. It will dissolve the organic soluble substance. We don't want organic solvents going down the drain. All right, so you see how I think you can see that. I'm using the acetone to rinse out the sep funnel into this organic waste. We don't want organic solvents going in the drain into the water system. Once I do one wash with acetone, I'll rinse out with water, and that'll take care of getting any of that blue soluble stuff that was water, the water soluble stuff out. And then I'm going to do one more rinse with acetone. So, at home in Gen Chem Lab, you might have cleaned with water only. And the reason you did that is most of the things that you're getting on you at home or in the Gen Chem Lab are water soluble. In an organic lab, by definition, a lot of the stuff, get my head down here, a lot of the stuff that we work with is organic soluble. All right, organic soluble stuff, as we just saw, won't dissolve in the water. So I can't clean organic material off of glassware with water much of the time. So I'm going to use acetone. Anyway, that's how you clean a sep funnel. At the end of the lab, you need to go and you need to clean up. Your beakers. And clean up your hood. All right, that does it for extraction.